Prostate cancer is the third leading neoplastic disease in men, following lung cancer and cancer of the large intestine. Because it completely surrounds the urethra, enlargement of the prostate causes compression, which can affect the urinary bladder and urine flow. The urethra itself is much longer in males than in females because it courses the whole length of the penis. Although it technically belongs to the urinary system, in males the urethra also has a reproductive function because it transmits semen during ejaculation. Urethritis, or inflammation of the urethra, can result from bacterial infections including sexually transmitted diseases, and manipulation of urologic instruments by healthcare professionals, and trauma. It can also be caused by ingestion of certain toxins. Classic signs of urethritis include a burning sensation during urination and a frequent urgent need to urinate.
Hi, I'm Mike Shively, and welcome to Introduction to Anatomy and Physiology. We're currently talking about the male reproductive system. Any of you have any questions? We're right in the middle of it. I think last time we had talked about testis and spermatogenesis. We had talked about the epididymis. We talked a little bit about the ductus deferens. Oh, incidentally, I got some of those figures, those gee whiz figures on sperm, if you're interested in numbers. A typical ejaculate contains between 40 and 250 million sperm per milliliter. Between 40 and 250 million per milliliter. And if you get less than 10 million sperm per milliliter, that's considered to be a state of oligospermia, it's called. Let's go to the overhead camera so I can put that word up for everybody. Oligospermia. This means few sperm. And that's less than 10 million. Per mil. And these individuals, these males typically have a very low fertility index. In other words, they have difficulty becoming fathers. So they're considered to be infertile but not sterile. Sterile technically is the inability, total inability to become a father because zero sperm or zero living sperm are produced. Another thing that was kind of interesting when I looked up these figures was normally sperm, or about 50% of them, have motility. In other words, they have their little tails are moving and they are motile. Incidentally, if you're curious, they move about 3 millimeters per minute on a microscope slide at least. And so you can calculate how long it would take them to swim all the way up the female reproductive system. The reality, of course, is that they can't, or they don't, because they have little sense of direction. You know how males are about direction and all. They won't stop and ask. You know, if we had to depend on the sperm from their point of deposition, someplace in the vagina, to get all the way through the cervix of the uterus, and all the way through the uterus, and all the way up the uterine tube, we'd have become extinct a long time ago. You know, the fact of the matter is that peristaltic waves from the female reproductive viscera actually get the sperm most of the way where they're going. When they get very close to an ovum, then there's some chemotaxis, and they sense that they're close to the objective and begin moving toward the ovum based on some chemicals that are released by the ovum. At any rate, less than 50% motility, if we get down to 40%, those individuals are considered to be relatively infertile too, if you get 40% or less motility in the sperm. Anyway, those are some interesting figures, I thought, that you might be intrigued by. Let's go ahead and talk about sperm just a little bit. We went through the process of spermatogenesis, but we never really talked about the structure of a sperm. They are among the smallest human body cells and really have a head, neck, and a tail, if you will. It's commonly called a tail. Technically, that long motile part of the cell is considered to be a flagellum. If we go to the overhead camera and kind of draw the structure, you can see that's the head, and there's a little thicker part right here that's the neck, and then it skinnies down for the long flagellum. All right, tail here. Its official name is flagellum. And by movements of this, there's a 9+2 tubule arrangement within the flagellum that you may remember from biology. The sperm are able to flick this tail back and forth quite rapidly. Matter of fact, when you're watching them through a microscope, you can barely see the movements of the tail quite often because it's moving so quickly. And they wander about, swimming like tadpoles, if you will. So that's what we mean by motility. If they're moving like that, then that particular sperm is considered to be motile. Now, the main part of the cell here has been reduced. There's very little cytoplasm in the head of a sperm. As a matter of fact, it's down to about 23 chromosomes with a bunch of mitochondria jammed in around in this neck area around the beginnings of those tubules. And so sperm cannot exist very long on their own. As a matter of fact, outside the male reproductive system in ideal conditions, they're good for maybe 24 hours. You might be able to stretch that just a little bit under ideal conditions. And some of the male accessory sex glands or secondary sex glands that add their secretions to sperm to make the fluid that we call semen, those secretions will contain some nutrients, particularly in the form of fructose. We'll talk about that in just a little bit. And there are also some buffers and some alkaline substances within that semen. Why do you think it would be important for there to be buffers and slightly basic substances, Adam?
Because the female reproductive system is a fairly hostile environment.
Yeah, the female reproductive system is, quote, as you say, a hostile environment based on the fact that it's slightly acidic, and sperm are really delicate cells and really can't take the acid environment. The acidity in a vagina seems to be there to help retard bacterial growth, because we have a warm, dark, damp environment there, and those kind of conditions typically promote the growth of microbial organisms. And so you're exactly right, the buffers are there in order to combat the acidity of the female reproductive tract. Anyway, those are some interesting things about sperm. Let's move on to the penis a little bit, and let me bring this model back up and let's kind of review. Since we looked at this in a previous session, so if we'll go to the overhead camera, and I just want to point out some of the structures we have talked about a bit. Here's the testis down in the scrotum, and the epididymis on the side of it, ductus deferens and other components of the spermatic cord, and we'll talk about what we mean by spermatic cord in a little bit, are going up this way. And following down here, then the ductus deferens finally plugs through the prostate and opens finally into the urethra at this point. Now this other structure, let me put this back up so that you can get the relationship here. This other structure sticking up right here is actually the ureter coming down from this kidney. So we got a kidney way up here off camera. It's not actually on this model. But it sends its ureter down, and the ductus deferens actually comes over the top of where that ureter plugs in to the urinary bladder. Just want to get you the relationship there. This ductus deferens is actually about 1.5 feet long, about 45 centimeters. That translates to about 1.5 feet in total length from where it comes off the tail of the epididymis down here to where it finally passes through the prostate to join the urethra. At any rate, we want to talk about the penis for a little while today. And we mentioned in a previous episode that it had a root consisting of left and right crura, and then there's a body here, and then the distal tip of the penis, which in an uncircumcised male has redundant skin called prepuce covering it. This model has been modeled in plastic as though at least this part of it has been circumcised, but this is called the glans penis. So again, root, body, and glans penis. Those are the basic parts from a regional standpoint. Now, if we were to, let me pull this part off, if I can get it removed here. So we've got a mid-sagittal section, The urethra, if you look carefully, is passing right down through, kind of in the lower aspect, the ventral aspect of the penis. Surrounding it is some erectile tissue, the red-colored material that extends clear out here into the glans penis is erectile tissue. And then there's also erectile tissue above the urethra. If we were to do a transverse section of the penis, I may have one up here that we can look at on camera, and then I want to actually make the drawing. So right here I've got a transverse section through the body of the penis, and you actually see three different erectile bodies, one here, and then down here is the urethra with another erectile body around it. Now when I say erectile body, I want you to understand that what we mean by that is some tissue that can be engorged with blood during sexual excitement to produce the phenomenon that we call erection. Let's go to the overhead camera and make that drawing that we were just looking at on the model. So we're going to say this is a transverse section of the penis through about the body of the penis. Down here would be the urethra. We'll just draw a circle and say that's the urethra. And then around it would be erectile tissue that is called corpus spongiosum penis. So that erectile body right around the urethra, I'm just going to put a big U in there for urethra to remind us what that is. Corpus spongiosum penis. Kind of a long term here. And there's just one of those around the urethra. Then up here, there's another erectile body, and over here, there's another erectile body. And these are left and right corpus cavernosum penis. Corpus cavernosum penis. Again, there's two of those, a left one and a right one, so I'm just going to put two in parentheses. Now these have very dense connective tissue proper encasements around them. So this connective tissue proper is very, very heavy and firm. It's called tunica albuginea of the penis. It's, remember we had that same kind of material surrounding the testis called tunica albuginea of the testis. So actually out here, of course, there's skin, very thin skin. And then there's tunica albuginea, that is that dense connective tissue. This is technically tunica albuginea of the testis. And then the erectile tissue itself within these three erectile bodies is, it has some connective tissue proper septi in it, and it has blood flowing through it all of the time. During the process of erection, during sexual excitement in males, the venous drainage from these erectile bodies is actually reduced. The amount of blood that's allowed to drain out of them is decreased, and the arterial input into those erectile bodies is increased. So if you turn the bathtub on big time and put the plug in, what's the bathtub going to do? It's going to fill. And that's what happens to these erectile bodies. Basically, if you kink off the venous drainage from those erectile bodies and increase the blood going into them, they will fill up. And basically the phenomenon that we call erection of the penis is a circulatory phenomenon wherein there's a lot more blood going in here. So these three erectile bodies become turgid, if you will, because they're filled tightly with blood. And then detumescence, or loss of erection, is just exactly the opposite phenomenon. The amount of arterial input is reduced, and the venous drainage is unkinked such that the blood can drain from those erectile bodies. Adam?
Is that controlled by the autonomic nervous system?
Autonomic nervous system, in fact, it influences the male reproductive system quite heavily. The vascular phenomena that cause erection are actually controlled by the parasympathetic division of the ANS, and the ejaculatory phenomena whereby certain muscles spasmodically contract, that's controlled or influenced by the sympathetic division. So parasympathetic division does the erection, and the sympathetic division does the ejaculation portion of the male reproductive process. And you know that sympathetic and parasympathetic quite often are antagonistic to each other in many of the roles in other parts of the body. So here's one area where the two are at least working together to some extent, although they have different responsibilities in the whole deal. However, more than one new husband anxious to consummate his marriage has been so fired up about the deal with the sympathetic division that the erection phenomenon fails, you know. And of course that's disheartening to say the least. At any rate, you have any questions about that internal structure? Bryce?
Just on the picture that you drew, so the tunica albuginea of the testis just continues up.
Did I
and
say
around.
testis? I did. Let's kind of change that. Why don't we call that the tunica albuginea of the penis, huh? Yeah, we'll fix that right here. I was just seeing if you were paying attention. Thanks, Bryce. All right, that's the internal structure, and that's about what I wanted to say about the erection phenomenon. Let's catch ourselves up and go up to a graphic and make sure that we remind ourselves that the penis does have a root that's divided into left and right crura. Now, these crura are just the left and right halves of the origin of the penis, and they attach to the left and right pubis. So the penis is physically anchored to the pubis. Remember, the pubis is one of the three bones that make up each hip bone, or os cocci. And then most of the length of the penis is the body, and then the distal tip, which is covered by redundant skin when we're born, when males are born, but that may be removed. That distal tip is called the glans penis. That redundant skin, again, is the prepuce. I don't know if we've ever written that word or not. Let's put it down. The name of that redundant skin is prepuce. So we'll just say prepuce covers the glans penis. Circumcision techniques have improved considerably over the millennia since I don't know if you remember, but reading in Exodus, Moses evidently was kind of shunning his duties. Evidently it was the father's duty back in those days to circumcise their newborn sons, and he wasn't doing it, so his wife Zipporah got fed up with it, and she grabbed a sharp stone, it says in Exodus, and did that particular procedure. I think the techniques have improved considerably since using a sharp rock. But it is intriguing, though. Some surgeons, for certain surgical techniques, are still using obsidian flakes because it's pretty difficult to get anything sharper than a good obsidian flake. All right, let's move on then, and we're going to spend a little bit more time on the secondary sex glands, or sometimes called accessory sex glands of males. Now, we've mentioned those before, and we looked at them on a model. We're talking about prostate, also called prostate gland. We're talking about seminal vesicles, and we're talking about the bulbourethral glands. Let's go to the second graphic here and take a look at the male accessory sex glands. Again, this can be called prostate gland or just prostate. Now, that particular one, remember, surrounds the initial part of the urethra. These are paired, and it's the secretions of these first two, seminal vesicles and prostate, that are added to sperm to make the fluid that we call semen. The bulbourethral glands, also known in some biology textbook as Cowper's glands, these do not contribute directly to semen per se, but their secretion is produced during sexual excitement and their secretion cleanses the urethra of the male prior to ejaculation, and most importantly, lubricates the gland's penis prior to intromission during sexual intercourse. Let's bring up a model and look at some of these structures again, just to remind ourselves where they are. So if we'll go to the overhead camera, this bulbous structure here is the prostate, completely surrounding the urethra. If we take this part off, then we can look down into the model and see the prostate sectioned with, in this case, the ductus deferens on this side coming down into it. Of course, this is the urinary bladder up here, okay? And so that's the urethra moving right down through the middle of the prostate at that point. Then, on this section of the model, I can turn it up and we can see part of the prostate here. It's been halved, of course, by the section. And then this is the seminal vesicle right here, seminal vesicle. And that structure coming in right there is the ductus deferens. And again, that's the ureter coming down from the kidney right here. So here comes the ductus deferens. Remember, the ducts of the terminal duct of the ductus deferens and that of the seminal vesicle combine to form a common channel right in here. It's called the ejaculatory duct. Now, the prostate gets its secretion into the lumen of the urethra by a series of microscopic ducts. So it has its own little channels that it adds its secretion into the urethral lumen. I looked up some of the specific contents of the prostatic secretion, and I just want to list them here. It's got a bunch of calcium ions in it. It has some acid phosphatase. It has citric acid in it, and it has clotting enzyme in it as well. That's just from the prostate. If we move to seminal vesicle, left and right seminal vesicles produce fructose, which is an important energy source for the sperm. They also produce prostaglandins, which stimulate the female reproductive viscera in that peristalsis, which helps move the sperm up toward the ova in the uterine tubes. And the seminal vesicles also produce fibrinogen. So that's I guess we probably ought to look again today. We saw it in a previous episode, but we probably ought to look again today at a model that will show the bulbourethral gland. Let me bring this model up and go to the overhead camera. Again, we've got urinary bladder with the urethra coming down through the penis here. This is prostate at this location. And then right down here is the very small bulbourethral gland, and it has a little tiny duct which allows its secretion to enter the lumen of the urethra. Adam.
Why does it form clotting hormone and fibrinogen?
When ejaculation first occurs, the semen is held in place by a clotting process similar to what happens in blood, the clotting of blood. And that may be to kind of keep the ejaculate close to the opening of the cervical canal in the female reproductive system. And then after a period of several minutes, the clotting material is broken down. That's the fibrinolysin material that we talked about. Breaks that clot down, and the semen actually liquefies. So evidently that's important in holding the material right against the opening of the cervical canal. And then it liquefies and is able to move on up. I guess it takes some time probably for the prostaglandins that are released to start stimulating the female reproductive viscera to help move those sperm up the female reproductive tract. Because they've got a bunch of centimeters to go, actually. Mm-hmm. And again, they're not directional in their swimming ability. Certainly at the beginning. It's right at the very end when they get very close to an ovum that they have some chemotaxis that moves them in. Any other questions? Now, the testis begins its development right next to the kidneys, just below the kidneys, which of course is up in the abdominal cavity up here. And during late gestation, the testis and epididymis migrate down through the pelvic portion of the abdominal cavity and out through the lower anterior abdominal wall and then assume a subcutaneous location in the scrotum. Let's go to the overhead camera for just a little bit, and let's say that this is a scrotum, and this is the rest of that guy, all right? So here's way up here at the top, we've got a testis. Of course, we got two of them, and the epididymis sitting on the side of each of these, and that's where they begin their development. Now, like all other organs in the abdominal cavity, they are covered in that location with serous membrane. So remember let me use a different color for that. Remember the serous membrane that lines the abdominal cavity is called peritoneum. So this would be parietal peritoneum out here. But the peritoneum that's right here on the surface of the testis and epididymis would be visceral peritoneum, would it not? There is a connective tissue proper structure called the gubernaculum, which forms it's kind of linear, and it kind of extends from the testis down through the lower anterior abdominal wall into the scrotum. And during development, it kind of shrinks up, and the testis kind of follows it. Now, it's not a rubber band effect, you know, where this is just stretched out and then boing, you let go, and the testis is flung down here into the scrotum. Not one of those deals. But somehow the ends of this gubernaculum actually enlarge during development and actually help make a pathway through the lower anterior abdominal wall big enough for the testis and epididymis to follow. Now, as they come down, let me just erase those. Again, that structure is called the gubernaculum. I guess I could write that word right here for you. Kind of running out of room, I'll sneak it over here. Gubernaculum. And as they come down, though, and pass through the lower anterior abdominal wall into the scrotum, they carry their investment of peritoneum with them. So when the testis and epididymis get down here, it's going to have peritoneum on the outside of it. Of course, the other one will be over here, same thing. And of course, the coming off the tail of the epididymis and still going clear back up into the abdominal cavity is going to be the ductus deferens. I'm just going to write D deferens here, okay? So the ductus deferens is going to get stretched quite a bit during the descent of the testis. So the testis ends up down here with its investure of peritoneum intact, and the peritoneum that lines the abdominal cavity comes down and actually lines the inside of the scrotum. Now, the two testes are separated within the scrotum by what's called the testicular septum. It's primarily connective tissue. So this lining peritoneum, if you will, just comes up on this side, and of course it heads on back up into the abdominal cavity through this narrow passageway. Now, intriguingly, for some reason, anatomists have given a different name to the peritoneum when it gets out of the abdominal cavity. It's the same stuff, and you can see it's a continuous red line here, but when it gets out outside the abdominal cavity, it's called vaginal tunic. Vaginal tunic. And so this right here would be parietal peritoneum. But that same material, when it gets down into the scrotum, is called parietal vaginal tunic. And up here, when the testis and epididymis were developing, just below the kidneys, up here, their peritoneal investment would have been called visceral vaginal tunic, which it is up there, but when the testis and epididymis get down here, that's called visceral, did I say vaginal tunic? Visceral peritoneum up there. When we get it down here, it's called visceral vaginal tunic. And finally, the space up here between various peritoneal invested structures is called the peritoneal cavity when we're up here within the abdominal cavity. But that same space, when we get down here, of course, is called vaginal cavity. So really it's a play on words more than it is a difference in anatomy as far as what we mean by vaginal tunic and peritoneum. It's the same material exactly, just given a different name. Eva?
Just wondering if there's some reason why they call it vaginal tunic. I mean, that seems confusing to me. It seems like it'd be something in the female reproductive
It
tract.
does, doesn't it? The word vagina in Latin actually means sheath. And certainly during sexual intercourse, the vagina ensheaths the penis of the male. This same stuff, when it gets down here, makes a coating or ensheathment around testis and epididymis. So at least that's the far-fetched logic involved in the nomenclature there. That is caused quite a bit of confusion, though, in the anatomy lab among anatomy students, because, you know, when you hear the word vagina or vaginal, you know, you automatically think female. But females, in fact, don't have a vaginal cavity. The space inside the vagina of a female is technically the vaginal lumen. So we say females have a vaginal lumen, which is the space inside the vagina. Males have a vaginal cavity, which is the extension of the peritoneal cavity down into the scrotum.
We're not really all that different, are we?
We're not. We're not. Now, the epididymis, we said, was continuous with the ductus deferens. Remember the tail of the epididymis? And so basically it's going to be pulling on the ductus deferens as this descent occurs. So the ductus deferens, which begins, you know, life up here in the abdominal cavity like the testis and epididymis do, ductus deferens, its initial part coming off the tail of the epididymis gets pulled right on down into the scrotum as well. And it's the structure that actually, when everything finally reaches its final location, it's the ductus deferens that actually passes through the lower anterior abdominal wall. So part of the ductus deferens is down in the scrotum, and the rest of the ductus deferens is up in the abdominal cavity. Now, the passageway through the lower anterior abdominal wall, which transmits the ductus deferens and the structures that accompany it, that go along with it, that passageway is called the inguinal canal. Let's write that on overhead camera for everybody. The inguinal canal, that's the passageway through the lower anterior abdominal wall, which transmits the ductus deferens and all those things that run with it. So it's a passageway. The ductus deferens and accompanying structures are called the spermatic cord. So we say the inguinal canal transmits the spermatic cord. And again, we'll define this as ductus deferens and other stuff that accompanies the ductus deferens through that inguinal canal. So we've got, trying to not get too circular in the definitions here, but Now, what does this other stuff consist of? In other words, what else passes through that inguinal canal besides the ductus deferens? If we do a transverse section through the inguinal canal and just the ductus deferens and catch these other things, if we say that, well, this circle is going to be the ductus deferens, okay, then there's a little teeny tiny artery and vein that run right with it. That's called the deferential artery and the deferential vein. So I'm going to draw a little tiny red circle and a little tiny blue circle here. So ductus deferens, I'm just going to write D period and D period for ductus deferens. And then that's a little artery and vein that run with it. I don't even think we need to label those because we got them colored at least. In addition to those, though, since the testis and epididymis went down into the scrotum, the neurovascular structures to those organs are going to be following the ductus deferens down. So in addition to the ductus deferens itself, we're going to have a testicular artery over here, get a little thickness to its wall. Then there's going to be several copies of testicular vein because it becomes redundant. It branches and branches many times to kind of surround the artery. Then there will be testicular nerve. I'm just going to put a solid green dot there for testicular nerve. And finally, in black, I'll say these are represents testicular lymphatic vessels. So if we have all of the structures here, it's testicular artery, several copies of the vein, testicular nerve, and testicular lymphatic. So those are going down to the testis and epididymis, and they're going to supply those particular structures. Now I'm kind of running out of colors here, so I'm going to use black again, and let me get rid of this line to the ductus deferens. If we actually surround these structures with the peritoneal investure that accompanies them, again, we're going to call this vaginal tunic, but it's peritoneum in reality. Kind of does this kind of a number right here. So this in here would be visceral vaginal tunic, this would be parietal vaginal tunic, and this would be that vaginal cavity that we talked about. Now the inguinal canal itself it kind of slants through the abdominal wall, and the openings at either end of the canal are given names. On the external side, we've got the superficial inguinal ring, which just is a little slit in the aponeurosis of the external abdominal oblique muscle. And then at the other end of the inguinal canal, we've got the deep inguinal ring, which is more of a kind of a triangular structure bounded by rectus abdominis muscle and internal abdominal oblique and inguinal ligament. So there's some names given to the ends of the inguinal canal. Superficial inguinal ring on the outside, deep inguinal ring on the inside. And so all of these structures that we've drawn here pass through that inguinal canal. I want to go back to the overhead camera for just a second because there is a slip of skeletal muscle that comes off the internal abdominal oblique and follows the spermatic cord down through the inguinal canal. So I'm just going to show it right here, say that's the slip of skeletal muscle tissue from the internal abdominal oblique. That's one of the abdominal wall muscles. And this particular slip of muscle is given a particular name. It's called the cremaster muscle. Being skeletal muscle, it's voluntary, and it allows males to elevate their testes by a centimeter or two, I guess in hostile situations. Maybe we mentioned in a previous session, you know, if you're high jumping a fence and clearance is critical, that might be one of the situations. But at any rate, cremaster muscle, it's not considered to be thermoregulatory at all, like dartos that we'll be talking about here in a second. But it does allow a male to when this muscle contracts, the testis, since it splays out onto the parietal vaginal tunic here, the testis and epididymis are elevated a bit within the scrotum. Eva?
I don't remember if you mentioned this last time, but why is it there's a difference in the structure of the artery and vein to the testes?
Oh, I didn't mention that, and this would be a good time to do that since we've just drawn it here. Let's go back to this overhead camera and take a look at our drawing again. The testicular artery is carrying core body temperature blood down to the testis. And we know that the testis needs to be a little bit cooler than core body temperature for optimal spermatogenesis to occur. And so its subcutaneous location within the scrotum allows it to achieve that slightly lower temperature. Well, since the testis is at a lower temperature, the blood within it is at a lower temperature, and the testicular vein coming back in several redundant vessels here surround the testicular artery. These redundant vessels from the testicular vein are called collectively the pampiniform plexus. Let me write that up here so everybody can see it. And what actually occurs here is a countercurrent heat exchange mechanism whereby the warmer blood in the testicular artery can be cooled somewhat before it even gets to the testis by some of the heat within it being absorbed by the slightly cooler blood traveling in these various branches of the pampiniform plexus. So that's one of the mechanisms that, that is in place to allow the testis to be somewhat cooler. And so the blood, when it gets down to the testis and epididymis, is already cooled a bit. Now, of course, it's moving pretty fast, and so it'd be, certainly, it's not going to get as cool as it otherwise might if it hung around for a long time. But that is at least the mechanism that has been explained for why we have that redundancy in the testicular vein. Any other questions on inguinal canal, spermatic cord? Adam?
What's an inguinal hernia?
An inguinal hernia is when we have abdominal viscera that's not supposed to pass through the inguinal canal. All those structures that we drew in the picture are supposed to go through it, but if a loop of intestine, for example, during extreme straining in a male, the weightlifters down the weight room will wear these big belts to kind of help prevent that. But sometimes abdominal viscera can be forced into the inguinal canal, causing some tearing. And then if a loop of gut goes through that inguinal canal, it becomes strangulated, its blood supply can be compromised, and then we can be in a situation where we can get some death of intestinal tissue, which of course is a serious emergency in the operating room if this does happen. Now you can have inguinal hernias where the loop of gut just kind of pokes through and becomes temporarily entrapped, and there's pain and discomfort associated with that. But a hernia is an abnormal protrusion of something through an area that it's not supposed to go through. And so, but at any rate, you ask about inguinal hernia, and that's what's going on there. Now, females basically have some small blood vessels that pass through the same region, but they don't have the same inguinal canal structure because they don't have a ductus deferens and accompanying structures to be passing through that region per se. Any other questions on this subject? Starley?
With the parietal vaginal tunic, you said that it went in and then up over the testicular septum. Does it just kind of loop around the testicular septum and then go down the other side?
No, I kind of shortchanged that drawing a little bit. Let's go to the overhead camera. We'll put the scrotum back on here. And this is the septum itself. Septum itself comes up here. There's actually, and we'll use red for the vaginal tunic. Comes down through the vaginal tunic comes down through the inguinal canal on this side and lines this in here. Then there's some of it that goes clear up here in the abdominal cavity across and comes down the other inguinal canal in like this. So it's not just a matter of going right over the top of the scrotal septum, because this kind of goes up and hooks into the perineal area. The testes actually have their own separate compartment. I guess it's like, trying to keep kids from arguing in the back seat or something. But the reality of it is that there's enough mobility here And when a male actually puts both thighs close together, the testes, most of us are not bow-legged quite enough for the testes to still be sitting comfortably side by side. So somebody has to take the low road and somebody has to take the high road when that happens. You see what I'm saying? Mm-hmm. Let's talk about this, the scrotal wall just a little bit since we're here. There are actually 3 layers to it. And if we'd have to get out a microscope to see the 3 layers per se, but on the outside we've got skin. And then there's a middle layer. It's called the tunica dartos. And it consists of elastic fibers and smooth muscle fibers kind of mixed in together. The smooth muscle fibers are actually called the dartos muscle, but there's enough elastic fibers mixed in with it that the combination is called the tunica dartos. And then finally, the inner layer, represented by the red line, is parietal vaginal tunic. Serous membrane. Now, this tunica dartos has a thermoregulatory function in that when a male is cold, the smooth muscle tissue within it automatically contracts significantly, thereby pulling the scrotum and the testes and epididymis on each side up against the perineum so that that they can get more of the body warmth. On the other hand, when a male is very hot, the smooth muscle tissue within the tunica dartos will relax and allow the testes to drop down further from the perineum. So we say that this smooth muscle tissue within the scrotal wall has a thermoregulation function in theoretically optimizing the testicular temperature. When my last son, our number 2 son, was in youth wrestling. We have a lot of wrestling programs around. It's really a great opportunity for the kids because even if you're little, which he wasn't, you can. It's kind of like soccer. Everybody can play soccer and have a good time. Not everybody's going to be a basketball center. But anyway, when Jeff was about 7 or 8, I guess, maybe he was 9, I don't remember. But at any rate, he was in a wrestling meet and had some kind of a move that either the other guy put on him or he put on his opponent, I can't remember. But anyway, there was a significant impact in his groin area, and he was in tremendous amount of pain. And after the meet, his scrotum began to swell up, and so we rushed him in to see a physician. And the physician became concerned that perhaps he'd suffered what we call a testicular torsion, which is when a testis gets twisted about within the scrotum such that the blood supply coming down to it gets kinked off. And of course, it won't take very long for the testicular tissue to die under those circumstances. So they scheduled Jeff for emergency surgery and opened up his scrotum. And by the time they got the surgery, got to surgery and everything, they went in and found nothing, turns out. And by the next day, the swelling had decreased significantly. Maybe there had been a torsion and it corrected itself before the surgeon got in there. I'm not too sure. But anyway, it was kind of one of those interesting emergency experiences, that you'll have 1 or 2 or 3 of as a parent. I remember Jeff was kind of nonplussed by the whole deal. He said that, riding a bicycle for the next couple of days was not a whole lot of fun. But other than that, he was just fine. So, any other questions about scrotums? Kind of interesting that there are some mammalian males that don't need to carry their testes around in a scrotum. Elephants don't have a scrotum. Whales don't have a scrotum. Bats don't have a scrotum. Then there are some mammalian males that only have testes in the scrotum during the breeding season, the so-called rut. And you're probably familiar with a lot of the artiodactyls, elk and deer, normally have their testes up in the abdominal cavity, and they periodically descend down in the scrotum during the breeding season. But most mammalian males have their testes in the scrotum all the time. Starley?
I know that with the last session we were talking about cryptorchids, where they
Yes.
never come down. Do they still have a scrotum of skin that kind of just sits there?
Yeah, but there's basically not much to a scrotum unless there's testes and epididymis in it. You understand? There's enough tone to the smooth muscle tissue in the tunica dartos that it tends to be pulled up pretty tight against the peritoneum, or perineum rather, if there's nothing within it. I think we mentioned in a previous session that, and in case you weren't there, don't remember, an individual that has a testis up in the abdominal cavity that fails to descend is called a cryptorchid. If both of them are up there, we call that a bilateral cryptorchid. If only one is up in the abdominal cavity someplace, we call it a unilateral cryptorchid. And I think we mentioned that a unilateral cryptorchid is normally typical in male reproduction in every way. In other words, father, children, and so forth. A bilateral cryptorchid is usually sterile. But the cells that produce testosterone found in the interstitial area between the seminiferous tubules, those interstitial cells are not interfered with or bothered by the higher temperature. So testosterone production remains normal. That means a bilateral cryptorchid is normally not impotent. We haven't used that word, I don't think, yet. Let me write it up here. So we'll go to the overhead. Impotent means a male is unable to maintain an erection. Bilateral cryptorchids are able to function reproductively. They simply are sterile. But as far as sexual intercourse, erection, sexual intercourse, it's not a problem. Adam?
Is that something they can correct surgically?
Yeah, that was asked about in previous session too, and there have been some surgical interventions in cases of cryptorchidism. Those are usually not particularly successful, although it depends on exactly how far up the testis and epididymis happens to be. They can be any place from not having moved from their original side development just below the kidneys up here, all the way down to where they're in the very lower part of the abdominal cavity, or they can be out within the inguinal canal, or maybe all the way through the inguinal canal, but just not quite all the way down into the bottom of the scrotum. So the techniques, depending on which particular case we're talking about, the surgical techniques may be more or less successful. They've also tried some hormonal interventions with varied success, same thing. Starley?
Sorry, you had just mentioned impotent. How does that occur? Like, why can't they keep the erection? Is it not enough blood coming in, or?
Well, there can be physical reasons for impotence, Starley, but most of the time, to be honest with you, it's psychosomatic. In other words, you'll hear psychologists say, and you know, jokingly, that the brain is the biggest sexual organ that we have, and you know, there's a great deal of truth to that, to be honest with you. So it's usually some kind of a psychological problem in most cases that causes that. Any other questions that you can think of? Adam?
If that's true, why have drugs like Cialis and some of the other erectile dysfunction drugs gained such popularity lately?
Well, if you think it's psychological and then you think you're going to get a drug that's going to solve the problem, you know, I don't know if they've done any double-blind studies where they actually give them the real drug and then they give them the, you know, the placebo. But if you believe that you're not going to have a problem with erection, then you're probably not going to have a problem with erection. Does that make sense?
Yes.
So if I've had a problem with erection, I get a drug prescribed to me that is supposed to solve my problems, then maybe I won't have a problem anymore at all. Because there are some physical phenomena associated with those drugs. They do play some roles in some of these circulation or vascular phenomena that we were talking about. And you know, I don't want to say that every case of impotence, Starley, is you know, strictly psychological, because some of them do have physiologic bases. And it has to do with the autonomic nervous system and the circulation phenomena. But quite often the thing that interferes with those are things up here, yeah. Any other questions? Eva?
I'm just thinking back to the transverse section you did of the penis earlier and showed us the three different erectile bodies, and there's one surrounding the urethra. When that fills with blood, does that impede the flow of fluid, seminal fluid, through the urethra at all?
No, it doesn't. As a matter of fact, it gets turgid. I think the lumen collapses in the urethra because it's not a stiff thing that the lumen remains patent when there's nothing passing through it. Let's go to the overhead camera for just a second because Eva brings up an important point. Let's say this is the urethra right here, and then we'll say this is the opening at the end of the gland's penis here. Okay. Now, the erectile tissue right around the urethra, which does completely surround it, called corpus spongiosum. When you get way back up in here, there's an enlargement of that corpus spongiosum body that is surrounded, actually, by a bulbospongiosus muscle, which is a skeletal muscle, actually. And during the ejaculation in a male, spasmodic contractions of this muscle right here squeeze, if you will, on this enlargement. It's called the bulb of the penis, this enlarged part of the corpus spongiosum. They squeeze on that and set up peristaltic shock waves that pass down through this erectile tissue, which actually move, Eva, the ejaculate through the urethral lumen. And there's also urethralis muscle in addition to that bulbospongiosus muscle that are involved in that ejaculation process. So there's spasmodic contractions during climax in a male that actually cause that ejaculation to occur. And I think we've run out of time. We'll talk about the female reproductive system next time.